Okay, so this is Unit 3 in geometry. We're doing types of angles related to polygons. We're going to start off mainly focusing on triangles. So the triangle angle sum theorem, I kind of hinted to this last class, that triangles angles sum to 180 degrees. So if you add up the three angles, angle A, angle B, angle C, they should all add up to 180 degrees in a triangle. The exterior angle theorem, it says the exterior angle is formed by extending any one side of a triangle. We talked about last time this being like the interior angle, and this be considered the exterior angle. It's on the outside of the triangle. An exterior is always equal to the sum of the two non-adjacent interior angles. So non-adjacent means the angle is not next to it. So in this case, angle 1 on the outside, this is our exterior angle, is equal to the sum of those other two interior angles. The reason being, if you think about it, a triangle adds up to 180 degrees, so these three angles add up to 180, and these two angles add up to 180. So by like transitive property, that would mean this angle and this angle should add up to the same as that. Kind of where that comes from. So we're going to apply these to some pictures and just find a bunch of missing angles. They always give you some angles in the picture, but you have to kind of remember some other things that we've learned, like a box is 90 degrees. So if you see a 90-degree corner there, just put 90 degrees there. Sometimes triangles overlap with each other, sometimes triangles are inside of other triangles, but let's say we want to find angle 1. This triangle here, those three numbers should add up to 180. So you could do 90 plus 43 and subtract that from 180. Or just do 180 minus 90 minus 43, that's 47. So now I know in this picture, this is 47 degrees, so I can put 47 down here in the corner. Angle 2. If you try and think about triangles, I just thought as angle 2 is supplementary with angle 43 because this makes a linear pair. Two angles together that make a straight line is a linear pair. So if you do 180 minus 43, this is 137 degrees. Write that right there, 137. And now, a couple different ways you could do this. You can think about this being a very skinny, obtuse triangle out here and do 12 plus 137 and subtract that from 180 to get angle 3. I've had students in the past see that this is one really big right triangle. So if they said 90 plus 47 plus 12, those all add up and subtract from 180 to get angle 3. So there's not like a one way to do these kind of things. You're just trying to figure out how to find the missing angle. It's usually related to 180 degrees. Okay? So if I did 180, if I just looked at this triangle, minus 137 and minus 12 for this angle down here, this skinny triangle, that angle 3 will be 31 degrees. Sometimes they give you information that would be helpful, like this. Okay, it says angle ACD, down here in the corner, is bisected by BC. Well, we know from last chapter bisected means cut in half. So if this is 90 degrees, we know each of these are 45 degrees. So next to angle 2, I'll put 45 degrees, and angle 3 is 45 degrees. Now you'll just take each of those two triangles you see, subtract those numbers from 180 to find the missing angles. So if I do this ABC triangle, I can find angle 1. So this angle 1 would be 87 degrees. I'll do the same idea down here on this BCD, this triangle on the bottom. 180 minus 45 minus 83. So angle 4 is 52 degrees. Alright. This last one I put put on here, so far all those angles that we're being asked to find were inside the triangle. This on letter C is the first time we have an angle on the exterior of the triangle. So come up with the way that you want to solve that. Whatever that is, you can use the exterior angle theorem that says the measure of angle 1 should equal 76 plus 52. Or you could take 180 minus 76 minus 52 and figure out this angle here is 52 and then subtract that from 180. That's another option on that. So if I do that, then this should come out to 128 degrees. So we don't care if you use the exterior angle theorem like this right here, or if you just know a triangle adds up to 180 and you kind of work backwards to find that. It's kind of like a two-step problem. Either method's fine. Alright, in this picture I have an equilateral triangle. We learned last time equilateral triangles are also equiangular, which means all the sides are congruent, you can see the little marks, and it means all the angles are congruent. If they're equiangular, 180 divided by 3 angles equals 60 degrees. So each of those angles have to be 60 degrees if they're all equal. So in this picture it says, if triangle PQR is equilateral, solve for x and y. So we know that equilateral means that all the sides are equal, so you can pick any two sides. Set equal. So let's say I pick 14y minus 59 equals 9y plus 1. Again, you can pick any two. I just happen to pick this one and this one. You solve, you would subtract 9 to the other side. You get 5y equals, I will add 59 to this side and get 60. When I divide, you get y equals 12. So the x value is in a corner, and because it says it's equilateral, it's also equiangular, which means all the angles equal 60 degrees. So to solve for x, you're going to set this angle, you'll see this is a little degree mark, angle R, 7x minus 3 equals 60 degrees, and solve for x using that angle. So 7x equals 63. Divide by 7, x equals 9. So angles are 60 and sides are equal to each other. Now it says, in triangle ABC has all congruent sides, meaning equilateral and equiangular. The measure of angle A equals that. Solve for x. So if it has all congruent sides, we know that the angle is going to equal 60 degrees. All angles equal 60 degrees in an equilateral triangle. This is a quadratic, so we're going to need to set it equal to 0 to solve. So I'll subtract 60 over and get minus 20. Then you would do your x method. The top number would be negative 20. The bottom number here, the number with x, would just be 1. So I need the factors of negative 20 that add up to 1. So I'll use a positive 5 and negative 4. That adds up to 1 and it multiplies to negative 20. So remember, you replace the middle part. Because that equals the 1. Then you call factor by grouping. You group the first two and you group the second two. The first two have an x in common. Remember, this sign goes with it, so I have a minus 4, so I'm going to put minus 4. When you divide by negative 4, you get positive x and positive 5. I know factored it correctly because my parentheses are the same. Okay, so you solve one answer, x minus 4 equals 0, so x equals 4. Subtract, you get x equals negative 5. So solve the triangle by angles and sides. Well, we know, classify. We solved for x. X equals 4 or negative 5. And then to classify it, sometimes I forget to do that part. We did the solve for x. We got that part done. That's the part most people do when they see the numbers. What people forget to do is, and I forgot to do, classify the triangle by angles and sides. So on this one, because it said it had all congruent sides, I know this is equilateral and equal angular. Those will always go together. Alright, let's look at the next page. The isosceles triangle theorem. Remember, if I go too fast, you can always pause the video or watch it again. So remember, isosceles triangles have two sides that are congruent. So if two sides are congruent, then the angles opposite those sides are congruent. So we call these two like the legs of an isosceles triangle. Then that means these base angles are congruent. So if these two sides are congruent, then these two angles have to be congruent. So solve for the variable. So you set the base angles equal. I'm going to subtract my x over and add 33. Then divide. X equals 8. Again, this one has us go a step further. Solve for the variable I did. Classify the triangle by its angles and sides. So, sides-wise, we know it's isosceles. It has two things marked. So I can automatically say it's isosceles. But the only way to know what kind of angles there are, because you can't guarantee it's drawn to scale, is to plug the number 8 back in your picture. So if I take 4 times 8 plus 7, that makes this angle over here 39 degrees. And you can double check, but 9 times 8 minus 33 should also be 39 degrees. So we have to find the missing angle. To find that, you would take 180 minus 39 minus 39, because those are both 39. This angle up here is 102 degrees. So, looking at my answers, since this is an obtuse angle, this would be called an obtuse triangle. So by sides, we have two congruent sides, that makes it isosceles. By the angle measurements, I know that this is going to be an obtuse triangle. On question B here, they didn't mark the sides, but they did show us that these two angles are equal. If these angles are equal, then that automatically makes these two sides equal. Because they're showing you that this is going to be an isosceles triangle by marking those angles congruent. So you'll solve by taking your x's to one side. Your numbers to the other side. You divide, you get x equals 3. Alright, again, because I can look at the picture and see two things were marked, I'm going to say it's an isosceles. But I need to figure out the missing angles. We know that angle is 70 degrees, this angle is 70 degrees. So to find the third one, you would subtract those two from 180. This is 40 degrees. Since all my angles, all three of them are acute angles, this is an acute triangle. So it is an isosceles acute triangle. quadrilaterals. Quadrilaterals sum to 360 degrees. Triangles sum to 180. The quadrilateral is 360. Find the measure of angle D in this quadrilateral. Well, all these add up to 360. So I would just take 360 minus 120 minus 95 and minus 85. So when you subtract all those, the missing angle is 60. Alright, the next one is called a parallelogram. Find the value of x. So one of the key factors, you will probably want this little sheet out from last time if you have it from your notes. If you haven't printed it out, you definitely want to screenshot it so you have this. But these would be the characteristics or properties of a parallelogram. We know opposite sides are parallel, opposite sides are congruent, but in this picture it looks like we're looking at angles. So it says opposite angles are congruent and consecutive angles are supplementary. So these two right here would be important to use in this case since we have angles in this problem. So you can choose to do this a couple different ways. A parallelogram means opposite angles are congruent. So you can either say 11x minus 2 equals 86, or you could do the consecutive thing and do 11x minus 2 plus 94 equals 180. It doesn't really matter. They both come out to the same answer. So we'll solve. Divide x equals 8. Just says find the value of x. So that property sheet will be helpful in knowing what we should do on these problems. This one is called an isosceles trapezoid. So we would look then over at our paper. In an isosceles trapezoid, we have this side is parallel to that side. This talks about sides, this talks about diagonals. These are base angles. Base angles are congruent. And opposite angles are supplementary. But here's the deal. Since these lines are parallel, I would just go with the one that says consecutive angles. And between parallel lines, consecutive interior angles sum to 180 degrees. So consecutive I just put consecutive interior angles, abbreviated there of course, equals 180. So we'll combine our like terms. 6x plus 8x is 14x. Negative 22 plus 34 is positive 12. And we'll solve by subtracting 12 to the other side. And we'll divide that by 14. Okay, I found x equals 12, but this one asked me to find the measure of angle T. Well, we have to decide, do you think angle T looks the same size as Q, or does angle T look the same size as R? Well, this angle and this angle are base angles that would be congruent. So I would say, taking 6 times 12 minus 22 is going to get me the angle that I need. So the measure of angle Q is equal to the measure of angle T, and we found that to equal 50 degrees. So that's what I would be looking for. So if you have this somewhere, you will want to know these properties so you can know, oh, can I set the angles equal, or are opposite angles equal? Are they bisected? Maybe you are going to have a bisected question. Maybe it's as easy as, oh, it's in a rectangle, so this corner is 90 degrees. It could be like this. These angles added up to 180 because they were consecutive interior. It might be a basic one like this, where all the angles just add up to 360 and you're trying to find a missing one. So knowing your properties of the quadrilaterals will be helpful to do the quadrilateral questions on the homework.